As we start our next chapter, we're going to be looking at what we call ratios. And basically, I've split into two boxes here some important information. So for ratios on the left side here, they can appear or they could look like a quotient, so using a division sign. So maybe an example of that might look like this. Maybe they might have okay, so a ratio could end up looking like that, and basically a ratio is looking at a proportion of two things. Okay, another way a ratio could come out looking like is a fraction. So an example of that might be like that. Okay, or it could come out using what we call a colon, and the way that that would look like is we have here's my example here in the pink. The colon could be the two dots. So separating them would be the whatever symbol. So either the division symbol, a fraction bar, or that colon. And the way that we would say this is 16 to 4. Okay, so all these examples that I've written here in the box, 16 to 4. So wherever the symbol is, whatever symbol they choose to use for to express a ratio, just know that that symbol is just a shorthand for the word 2. Okay, so a quotient using a division sign, 16 to 4. Okay. 16, the fraction bar is the word 2. 16 to 4, the colon is 16 to 4. Okay. So, because we're comparing two things. Okay. Some steps for this is to rewrite the ratio as a fraction. So if it's not already a fraction, you're going to need to put it into fraction form. Simplify. So just simplify the fractions just as we've been doing for forever in the last few chapters. And for some of them, they might give you some units of measurement like centimeters, inches, hours, minutes, whatever you could think of. Centimeters, feet, inches, meters, all of that stuff. So you might need to convert to units, and so it's important that you do that because for you to be able to simplify these ratios, they need to be the same type of units. And then put the ratio back in its original form. And so again, I give you this reminder that if there's units given, the units need to be the same when you give me a final answer and when you simplify. So let's look at some examples so this can make a little more sense here. So write each ratio in simplest form is the directions. So I've given you this, and so it's 18a b squared to 14a squared b. And so the first step, remember I told you, was to rewrite the ratio as a fraction, but lucky for us, it's already in a fraction. Okay. Step 2 is to simplify and to be sure to convert units if we need to. So looking at number 1, do you see any kind of units of measurement, like a time measurement, a length, maybe a weight, anything? No, okay, it's just a regular fraction, so there's no worries about having to convert anything, just simplify. Okay, so we know how to do this already. So 18 and 14 is going to simplify to what? They both have a 2 in common, so 9 over 7. Okay, let's look at the a's. So where's the bigger a? The bigger a is on the bottom, which means that when we simplify, the leftover is going to end up on the bottom. So remember, wherever the bigger exponent is, that's where the leftover goes. For the b's, the bigger exponent's on the top, so the leftover is going to go on the top. So all that's left is just 1b. Step 3, put the ratio back in its original form. Its original form was a fraction. The way we've simplified is a fraction. So that's good. We're done there. Okay. Let's look at number 2. So number 2, this time I did not write it as a fraction. I wrote it as using the colon. So 45x to 30x. First step is to rewrite it so that it is a fraction. Okay. Second step is to simplify. Do we need, and also to check if we have any units of measurement here. So do I have any length or weight or time measurements here? I don't, right? It's just 45x and 30x, so no units of measurement, so I don't need to worry about converting. And so let's just go to the simplifying. We have 45 and 30 So what I'm going to do here is, let me get my marker going here, 45 and 30. Let's work on simplifying these two guys. So looking at it, what is something that they have in common? They both have a 15 in common, right? So 45 into 15 is going to give us 3, okay? 30 into 15 is going to give us 2. Looking at the x's, what happens to them? They both end up canceling, so all I have left is 3 over 2. Okay, my third step is to put the ratio back in its original form. So its original form is going to end up being using the colon. So instead of writing this as a fraction, all you do is you rewrite it. So you have the 3 and the 2, and then you put the colon in between them. Okay, so that's what step 3 means when I say to put it back in its original form. Go back to the original problem, see how it was written. To simplify, you need to put it as a fraction. I think that will be the easiest for you. But when you're going to give me the final answer, once you've simplified as much as you can, then go back to the original problem and rewrite it the way that it looked like originally, which was with the colon in this case, okay? Alright, so hopefully you've kind of gotten a little used to the simplifying part for the ratios. Let's go into this one's to 3 and 4. So now I have ratios, and I'm tacking on the units this time. So I have 3 hours to 15 minutes. Okay, so that's a MIN here. Let's make that a little clearer. Okay, so I have 3 hours to 15 minutes. So first step would be to rewrite this as a fraction. Okay. And then now, before we simplify, we're going to need to get it into the same type of units. Okay, so we can't simplify things when the units don't match up. So since I did not specify which units I want you to solve for, always assume you're gonna convert to the smaller unit. So is the hours smaller, or are our minutes smaller? Hours smaller or minutes? Minutes is the smaller one, so like I said, because I didn't specify which units I want you to solve for, always just solve for the smaller one. So we figured out that the minutes is the smaller measurement of units than the hour. So how many minutes are in 1 hour? There's 60 minutes in 1 hour, right? So before we simplify, we have to get them to match up. Because I didn't tell you what to solve for, just assume you're going to solve for the smaller one, which is the minutes. So my goal is to get both the top and bottom to match in minutes. So the bottom is already in minutes, so I can leave it as 15. But like I said, the hour is not. So we figured out how many minutes are in an hour. You guys told me 60, right? 60 minutes an hour. So the way that you would convert this is you're going to go times 60, because there's 60 minutes in an hour. So now I have 60 times 3 is 180, and so there's 180 minutes or 3 hours. Those two things mean the same thing. So one more time, listen. This problem has units in it, which means I'm going to have to do a little bit of converting because I did not tell you what to convert to. You go to the unit of measurement that was smaller. So between hours and minutes, the minutes is smaller, so I converted. Okay, so both the top and bottom of the fraction is going to be in minutes. The bottom was already 15 minutes, so I didn't have to make any changes, but the top was in hours. How many minutes are in an hour? 60, so I did 60 minutes times the number that was given on the top, which was 3. 3 times 60 is 180. Now that I have both of my units of measurements matching up, all I have to do is just simplify, okay? So how many times does 15 go into 180? So believe it or not, goes in 12 times. So they both have a 12 in common. So, I'm sorry, they both have a 15 in common. So 15 actually does go into 180. So here is how this goes here. So you go divide by 15. Okay, divide by 15. And what you end up with is on the bottom, you end up with 1. 180 into 15 is actually 12. Okay, and so we have 12 over 1. Once you've simplified this, the minutes, if you're dividing them, they both cancel out, right? And so last step is to put it back in its original form. Its original form was in a colon, was using a colon. So I go 12, and then instead of the fraction bar, I'm going to put the colon 1. And then there we go. Okay. Let's try the same thing with number 4. So in number 4, 9 inches to 15 feet, first step is to rewrite it as a fraction. Or 9 inches to 5 feet, I'm sorry, not 15. 9 inches to 5 feet, write it as a fraction. I have units of measurement, so I'm going to have to do a little bit of converting. Did I specify how I want you to convert it, though? I did not specify, so you're just going to convert them into the smaller unit. So let's draw a fraction line, which is the smaller unit, the inches or the feet. The inches is the smaller one, so I'm just going to rewrite inches here so that we don't forget that that's what we're solving for. Which one does not change? The top doesn't change, it's already in inches, so I can just rewrite that. Okay, 5 feet, so how many inches are in 1 foot? There's 12, right? 12 inches in 1 foot, so I'm going to write a 12 there because I'm going to multiply that number with 12 because there's 12 inches in a foot. So I get 5 times 12 is 60 inches. Okay. Last step here is to just reduce the fractions. So if I reduce these fractions, what happens to the inches here? Since they're both on top of each other, they're exactly the same. They cancel out. Okay. 9 into 60, they both have a 3 in common. So if they both have a 3 in common, we end up with 3 over 20. I cannot box this yet. My last step is to check and put it back into the original format. Original format was using a colon. So I go 3, colon, 20, done. Okay, so if you're confused about why in 3 and 4 the minutes and inches cancel out, it's because remember when you have the same thing on top of each other in a fraction, it cancels out. So 2 over 2, 100 over 100, remember to cancel out. X over X, when you have the same things on top of each other, they all cancel out, so that's why the minutes and inches end up canceling out. Okay, so that's really the gist of it. Again, the toughest part here is the converting part, I think, so you guys got to be familiar with how many inches are in a foot, or how many hours, or how many minutes are in an hour. I think in your planner it's in there. There's some basic conversions in there. So if I don't tell you what to solve for, just assume you're always going to solve for the smaller unit of measurement. So again, in 3, the smaller between the two is the minutes. In number 4, the smaller between inches and feet are inches. Okay, so solve for whatever the smaller one unless I say otherwise. And that's it.